Hi everyone, my name is Zhiheng Jiao, and I'm from the Math program. The topic of my thesis project is Generative Design System Framework for Space Aggregation. There is the question that I want to bring to the discussion. How will architects work in the future? This project is about the potential answer to that question. I will explain that with more context. Briefly speaking, given this continuous developing technologies we have, the workflow that I propose is that architects actively develop variants of generative design systems for the project on the fly in the design process using a framework. Here is a brief history of the transformation of the design process. Architects work closely to the construction site, and their deliverables use usually the building itself. Then the format of the deliverables were transformed into the representation of the building, which were hand drawings, plans, or sections, and now they are 3D models or CAD drawings. This transformation implies that the deliverables of architect is also transforming from the entity of the architecture itself to the inner design or build logic of the architecture, which is an idea of the generative design systems. Generative design system can be understood as design machines and structured knowledge. It is usually constructed through programming in this era. Another context is the current programming interfaces. It is much easier to write a piece of working code than before and can produce more feasible outcomes easily. This brings to the opportunities for architects to take programming as their new skill set, just like CAD and 3D modelings in the old days. There's an example of the Scratch. It is designed for the children to learn how to program, and it requires very few prerequisite computer science knowledge. Here's a roadmap of my presentation. After the introduction, I will talk about the design process that I mapped out. Then I will use a specific example in space aggregation as a case study to further explain my idea and showcase my development of this framework. Finally, I will come back to this broader discussion on a new design workflow. On the left-hand side, I mapped out the thinking process based on the interview to architects. The circles represent different stages in design process, and the vertical and horizontal dimension represents the breadth and depth of the design solution space. One explanation is that the information is needed to resolve architectural design problems is often not readily available during the early conceptual stages, requiring proposals to be evaluated only after an initial solution is reached. At the beginning of the design process, architects usually test different strategies to get a perception of the breadth of the solution space. Then after the initial solution is reached, the depth of the solution space can be determined. Then architects could go back to previous stages to make different design decisions for optimization. The problem of this process is that knowledge you get from these explorations is not structured, which means you need to execute iterations of design by yourself every time. This brings the advantages of using a generative design system, which is by defining the design iteration logic, you can execute the iteration by simply changing the input parameters of those processes. There are already generative design tools applied in the industry. For the generative design tools, there are three possible patterns. They are the directed visual programming, framework, and compressed tools. The directed visual programming here is basically Grasshopper. It's easy to use, but it has limited control flow, and because it is for low-level geometric manipulation, it has low modularity for reuse. The framework is the pattern I propose, where it is highly customizable and has full control flow and hides the complicated utilities behind the interface. It is versatile and reusable for similar problems. And also the compressed tools are basically packed solutions for specific problems, and they are fully automated. In this thesis, the framework that I propose is in the context of space aggregation. From the literature, architecture can be seen as a combination or permutation of geometric elements. Space aggregation has the same logic, where I define it as hierarchical composite of spaces. For instance, a room is the composite of furniture and walls, and a hotel is a composite of rooms, staircases, and corridors. The frame that I developed is based on the parking lot design, so I will talk about that in detail. If we decomposite the parking lot, we can find that each part of it can be deconstructed until they are too small to further decomposite at this scope. This composite pattern matches the design model of human, where we split a larger problem into smaller ones. It also implies that we can treat each space composite the same as a single space element. Here I call it a metaspace. In the diagram of parking lot on the right, from the top level, each level of spaces serves as the ingredient of the next level composite. This brings to the development of the software framework. I designed and implemented this software framework for parking lot design. Here I use this graphical notation to represent different parts in my real program implementation. For each solver of this framework, the input and output are all space composite. The 5 components of the solver defines the application-specific solver. To solve different problems, users of this framework can create different variants of those 5 components to form a new solver. As I showed earlier, the parking lot design process can be divided into several parts. Here I take the role solving process as an example. The input of the role solver is the inner boundary of the site. The metaspace is the parking stalls with different angles. The solver here generates rows of stalls and fill the given zone. The evaluation formula is basically compare the stall counts among all results, and the solver will finally pop up the best few results for the next solver. Here is a demo of the system. The layout is changing in real time based on the site as input. The result of boundary solving feeds into the role solver and forms the whole parking lot layout. There is a demo for another configuration. The result is selected and sorted by the total stall count. And here I listed out some of the output of the system. Now we can come back to this larger conversation in space aggregation. The composite pattern in parking lot also applies to other types of design, such as the office layout here. This building can be divided into several divisions, and each division is a composite of desks and chairs. The framework and solver could also possibly apply to this design problem. Compared to the parking lot composite, the office composite has similar properties and can be disassembled using the same model. This means that the framework designed for the parking lot has universal potential. Through different implementations of specific solvers, The office layout can also be designed with an office-specific variance of the framework. Combined with the lower and lower programming threshold and more auxiliary tools, this method of designing with a framework by changing or adding logic is likely to become a common working method for future architectural design. The outcome of the project is twofold. On the one hand, this project provides a new perspective of interpretation on architecture and the design process. On the other hand, in this project, this composite idea has been tested by the implementations of the parking lot design framework. This framework actually can be seen as a middle place between fully automated tools and parametric design tools such as Grasshopper. It represents a new design tool scheme that keeps high level of customization and also integrates the composite pattern for reuse and iteration. In the current implementation, there are many missing parts, such as the lack of user interface for architects to do the customization or knowledge-based engineering, and now the skill required for customizing the framework is not trivial. Also, to make the framework truly general, there are more works has to be done in the backend. But I think it is able to represent a possible future workflow where architects could essentially be customization developers for generative design frameworks. Well, that's about it for now. At the end, I would like to express my appreciation and thanks to Jeremy, Heather, Josh, and Pedro for their patient guidance and advice in the project. Thank you so much for your time and patience.